So I think we can start. Good morning to everyone, and welcome to the invited talk by Dr. Virginia Garcia Millan with title Mediterranean Forest Map. We will start with a short welcome note and then we will proceed to the talk. The talk is recorded, so please keep your cameras off and your microphones. We will allow questions through the chat and we will address the question to the speaker after the talk. At this point, I would like to invite Dr. Kyriakos Themistokleous, Project Manager of the EXCELSIOR H2020 Teaming Project, for a short welcome note.
Yeah, good morning to everybody. I would like to welcome Dr. Virginia Garcia for her invited talk on the Mediterranean Forest Map. She's a remote sensing expert at the European Topic Center at the University of Malaga in Spain. Her professional interest is nature conservation using remote sensing and GIS. She got a first master degree in integrated Mediterranean of coast by the European consortium edu.com in 2007. She obtained her master degree on remote sensing and GIS in 2008 at the University of Autonoma of Barcelona in Spain, followed by a PhD on remote sensing on ecology at the University of Pablo de Olavide in Spain in 2012. Later, she had 2 postdoc fellowships at the University of Alberta in Canada, focused on LiDAR and UAV technologies for the monitoring of forest and agriculture from 2015 to 2018. Also, she has experience in the private sector as she worked in the EFTAS in Germany from 2012 to 2015, and Skymatics Ltd in Canada from 2017 to 2018. So, Dr. Garcia, we're waiting for your speech and we would like to see what you're going to show us today. Thank you very much.
Thank you very much for the introduction. Can you hear me well?
Yes.
Yes.
Okay, so let's see if I can share my screen. Okay, can you see my screen now?
Yes.
Okay, let's see if I can go to slideshow. Okay, well, thank you very much for inviting me to this presentation. I'm very proud of it. And thank you for the presentation. So yeah, just as a reminder, I work at the European Topic Center at the University of Malaga in Spain. And these days I'm working on a project to develop the Mediterranean forest types map that is based on dominant species. So many of you may wonder why are we doing another forest map? And this is a funny question because whenever I talk to friends or even colleagues in the matters and they ask me, what are you doing these days? And I say that I'm developing a forest map for the Mediterranean, that is a very well-known area. They are kind of surprised that they always ask me, but isn't there already a map of forests? And I said, yes and no. So actually there are some maps and I will explain very briefly what are we contributing? Why are we doing a new one, right? So effectively, there are some forest maps for the area. And I'm showing some examples of very common forest maps that we have available for the area. For instance, we have the Global Forest Watch map. Also, the Copernicus program from the European Space Agency, they develop at the global level a land cover map, and there's a couple of layers for forest. So they have open forest and closed forest, and they even separate the forest in several classes, like for instance, evergreen needle forest or evergreen broadleaf forest, mixed forests, and things like that. Then we have only for the European part of the Mediterranean, we have the Corinne land cover that has been developed since the 90s, and it has like a more detailed and even accurate definition. And there are some classes like coniferous, broadleaf, and mixed forest. And then we have also from Copernicus the high resolution layer of forest. And this layer is at 20 meters of pixels, so that's why it's called high resolution layer. So why to do a new forest map, right? Well, first of all, also let me comment that there are also maps developed by every country if they decide to invest money in developing their own forest maps. So there are some countries in the Mediterranean basin that they develop their own forest maps. So for instance, I'm showing here an example from Morocco and also another example from Algeria. But many other countries in Europe as well, like Spain or Italy, they also have their own national forest maps. So the first thing we did is we did an assessment of what is the quality of these maps, because we consider that the cartography of forest is still not good enough for certain applications, especially if we want to contribute to forest management at the local level. We wanted to find out if these maps are good enough and they can be used for this purpose. So we did at the very beginning of the project, we did an evaluation of the maps that I'm showing you, and we found several limitations. So for instance, those maps that has a better resolution, accuracy, they have a very broad pixel size. So for instance, the Corine land cover is considered a very good source of information, like the very good quality, because these maps are done with photo interpretation, and they have the support of a lot of field data and field work. But the product has a 100 meters pixel, so the resolution might not be that well. And then also it only covers the European part. So if we want to develop a map for the entire basin of the Mediterranean, of course, most of the countries in the basins are out. So all the countries in Northern Africa, in the Middle East, they are not covered by this product. Then other products that are produced more with automatic techniques, like the Copernicus high resolution layer and the global land cover, we found that the accuracy was not good at all. And in this table down here, we basically evaluated some countries, excuse me, and compared the values they report for forest surface. And we compared it with the forest resources assessments that the countries provide to FAO, to the Food and Agriculture Organization. And we found that the numbers are really different. Of course, you have to take into account that maybe the reference, the forest resources assessment, might not be a super good reference. But even though whenever we report and compare what these maps are reporting towards what the countries report, we found that for certain countries that are out of Europe, for instance, for Tunisia and for Lebanon, the errors can rise to up to 78% of errors. So the maps are pretty much useless, right? And also, when it comes, for instance, to the national inventories and national maps of forest, those maps takes a lot of time and a lot of effort to be done because of the process of developing them through photo interpretation and supporting them with field inventories. So these maps are produced every 10 years, more or less. So we have, like, the context of the cartography, existing cartography of forest, it's a bit limited for many purposes. In that sense, our motivation was, okay, we would like to create some forest maps that covers the limitations of the existing cartography, taking into account that we want to create a product that is useful for forest management at the local scale. So several things that we want to improve. are related to creating a method that allow us to produce a map of forest yearly, so we can have a map every year. Also, we want to have a map that has a nicer pixel resolution, or what is called like this scale of the map is more local. And we want to go to a level of 10 meters resolution. We also want to create a map that has the same quality for all the countries in the Mediterranean basin. So we don't want to have a map that has a high quality in Europe and a bad quality in Northern Africa, for instance. We want to create a map that is homogeneous in quality in all the region. But also we want to go one step forward, and we would like to make a map that differentiates types of forest based on the main composition of trees species. Because, for instance, the classes that we have now, like coniferous, mixed forest, broadleaf forest, is not good enough for many applications. For instance, if you think about people who is thinking about assessing non-wood resources, they need to know what type of forest it is. They need to know if it's a quercus forest, if it's a castanea forest, and things like that. And so far, these nobody has done so far for the Mediterranean region, okay? So the idea is that with this type of forest, we would like to contribute to forest management and also to fill the gaps between forest inventories that they happen more or less every 10 years, or even have an extra source of information to help the forest management, okay? So yeah, as a summary, our aim, our goal is to create a Mediterranean forest map for the entire Mediterranean basin based on the forest types on dominant species. Okay, so for that, we thought that we need to take a use of homogeneous data. And that involves, for instance, we thought the best way of addressing this problem is to use satellite data, because the satellite data is the same for all the Mediterranean countries. And if we want to create maps every year, we could use artificial intelligence and automatic methods to create those maps every year, because the area to cover is very large. But also the artificial intelligence helps that whenever we have an area with a lot of data, field data, like for instance, I'm going to talk a lot about Spain. We have a really nice database of forest inventories for Spain. Maybe those areas can help to cover gaps in information in other areas that don't have so much field data, okay? So just to define and what is the area of study that we are covering, this map is showing the area that we will cover. Basically, we are using the definition of a Mediterranean ecoregion defined by the World Wildlife Fund. And when it comes to forest and the forest types, we are using the definition of forest given by FAO, the Food and Agriculture Organization. So forest must be a surface covered by trees, but the coverage must be more than 10% of tree cover. At least the patches of forest must be 0.5 hectares. Then the tree height of must be at least 5 meters. Within this definition, we include forest and other woodlands. For instance, plantations are also covered by this definition, but we leave out urban parks and tree crops. And then we will differentiate also between open forest and closed forest. And yeah, FAO gives also the definition of broadleaf forest, coniferous, mixed, bamboo and palms, and we will go one step forward. When it comes to the definition of the forest types, I was also surprised that there's not an agreement about what forest types there are in the Mediterranean region. So my first approach was to do a literature search to find out how many classes do we have of forest types in the Mediterranean and which are they. And it's somehow surprising that there's not a the Bible of Mediterranean forest types. There are many definitions by different countries and institutions. So the first efforts we had to do is to come to an agreement on what classes are going to be included in the map, in the legend of the map. So we took as a starting point, for instance, several sources of literature, but among others, the UNIS habitat classification. So this is the European Union definition of habitats. And of course, you can see in this list, and there's 2 pages of this list, that some classes are defined in the European legislation, but some other classes don't exist. For instance, I'm putting this example of some forest types that don't exist in Europe, but exist, for instance, in Northern Africa. So for instance, the Argania forest and the Acacia forest. But I was surprised that some species and forest types are very, very common in the European Mediterranean part, like cork oak forest and the gall oak forest, formed by Quercus suver, Quercus canariensis, Virginia, Pyrenaica, and Lusitanica. They are not classified in the European habitat classification. I was a bit surprised because it's basically very common in the South Mediterranean part. So this is the second part. So just showing you that all the types that we are considering, this is still ongoing. So maybe we will add more classes, but these are the starting classes we decided to include. So this is the list of coniferous forest, broadleaf forest, but also we have mixed forest. We are classifying mixed forest and also some plantations, okay? So as I mentioned, this is a provisional list. We're still in discussions with several experts about what species and forest type shall we include in the map. And but by the moment we have 36 classes of forests that we will divide in dense and open, so that will double the number of classes, and 10 classes of plantations, okay? Also, this will be provisional for other reasons that are more technical and related to remote sensing, and I will explain later. So a very, very brief definition of the method. Basically, as I was hinting before, we are using satellite data and artificial intelligence to produce these maps. So let me introduce that we are using the data from the Sentinel-2 satellites, and that satellite has a camera that is a multispectral camera. So a multispectral camera is basically taking photos of the surface of the Earth, and some of the photos are similar to the ones you can take with your phone, like they are covered in the red, blue, and green bands, but also they cover near infrared bands. Okay, so with a combination of visible images and infrared images, we can retrieve much more information from vegetation than with only visible images. And also we are combining the work with data from another satellite that is called ASTER, and this satellite belongs to NASA and the Japanese Space Agency. Sentinel-2 is from Copernicus from Europe, and ASTER from NASA, from American and Japanese agencies. And this satellite provides a digital elevation model. So in this case, basically is an image that shows the topography, the elevation of the terrain. And I thought that that's a very important variable, because the Mediterranean forest is really related to the distribution of the Mediterranean forest type is really related with elevation. So there's like a distribution of different forest types along the slopes of mountains, and they organize very well related to elevation. Okay, so how do I transform satellite images, or several satellite images, into a map? So basically we use a computer and artificial intelligence. So we use something called machine learning, and it only consists that I'm going to teach my computer how to differentiate a forest type or a land cover class. So first of all, let me introduce also that the methodology is structured in 2 steps. So in a first step, we do a land cover map. And within the land cover map, we have 2 classes of forest. One is a dense forest and another is an open forest. Whenever we are happy with this land cover map, then we extract that layer and create a forest map based on species. So we do a first classification to create the land cover map, and then a second classification to produce the forest type map. So how does the machine learning work? So basically, I provide my computer with an image, like a satellite image. And also, I have a database to support the labeling of the images. So from the database, I locate different classes on the image and create a number of samples. So for instance, I cut a little piece of the image and identify, thanks to the database, that this is a lake. And then I show to my machine and I said, look, this little piece of image, this is a lake. Then I show a little piece of image that is a forest and show to my machine, this is a forest. And I do so over and over for all the land classes, land cover classes that I have. That is forest, grasslands, cities, agricultural land, water and wetlands and things like that. And then whenever after I show the machine thousands of samples, and then I give my machine any image and tell, okay, I want you to classify each of my pixels and tell me what class they are. So that's how the machine converts an image, satellite image, into a map. So first, the teaching is around land cover classes, and we have a list of 9 land cover classes that are very generic, like I was mentioning before, like forest, open forest, agriculture, cities, shrublands, grasslands. And whenever I'm happy with the map, I extract only forest and open forest and do the same and teach a new language, let's say, to my machine. And now I'm teaching the machine forest types. So I take a new database and I cut pieces of image, and then I tell my machine, okay, this is a Quercus forest, Quercus ilex forest. This is a Pinus brucia forest. This is an eucalyptus plantation forest. And I show as many classes as I want to define. And again, I show thousands of samples to the machine until the machine can recognize the forest types. And then I give again the same images and say, okay, now tell me what forest types are there in this image. And something that is important for you to see also is that from the databases, we use the 80% of the points for the machine learning to teach the machine and do the maps, but we save 20% of the points to do a validation process. So a validation process is later we're going to check how good the map is, and we will identify the errors of our maps. Okay, we save 20% of the points for the validation process. Another important thing that I want to point out is that for the first step, the land cover map, we managed to retrieve data from 3 countries, Lebanon, Spain, and Tunisia, while for the forest types, I managed to have mostly data from almost all the countries in the Mediterranean region. So I will show you later. For those people who are more into remote sensing and control more the technical parts, I'm showing you a more detailed scheme of the methodology. So I want to show that actually we are not only using the 12 reflectance bands of Sentinel-2, we are also using some spectral indexes, and I'm listing here the indexes that we are using. And we worked with data from 3 different months in 2021. So we use March, June, I don't know why it's not shown here, probably a mistake, sorry. data from March, June, and November. And more or less the satellite passes every 5 days. So every month we have between 3 and 5 images. And we do a monthly composites based on the median of values. We also remove clouds before doing so. But we are using so far only data for 3 months because of a matter of data processing and computation and so on. And we use those composites for the 12 bands, but also the composites of the spectral indexes. When it comes to the digital elevation model, we are using the information about elevation itself, but also we calculate slope and aspect and include them as variables into the model. And we are also considering latitude and longitude as variables of the model. So for those that are interested more in the techniques, the classifier that we are using in both steps is the random forest. And we are also doing previous steps of data normalization, okay? And we are doing some analysis of spectral separability as well to help the random forest and to evaluate what classes can be separated. And at the end of the process, you can see here, the validation basically is evaluated through a confusion matrix. Okay. So as you could guess, so one of the big things or more important things of the process is to have good and solid data from the fields. So basically we retrieve forest and land cover inventories from the Mediterranean region, and we did a huge effort in collecting data. So here I'm listing you the different types of data that we are using. So for instance, a big source of data for forest types comes from the European Vegetation Archive, and here you have the link. And this is an initiative of researchers along the European countries that they produce their own data for their own studies, but they also want to share that data for other researchers to do other studies or use the data in other applications. So the data is available, but you have to do a request. It's not that you can just directly download from the website. And normally you submit a request for data and they take 3 weeks to reply to you. Then we also consulted some national forest inventories and land cover data. And for some cases, like the case of Spain and Italy, the data is for free and available. You just can directly download it from the websites. But also for other countries, it's not the case. So for instance, for Lebanon and Tunisia, we managed to have some national forest inventory and land cover data. And that was achieved because we did collaborations with the ministry of those countries, okay? In other occasions, we had the expert contribution of people who knows the area very well, like the case of Morocco. And also we contacted other researchers that don't belong to the European Vegetation Archive, and they kindly share their data. Like it's the case for some countries in the Balkanic Peninsula and Turkey. Okay, so let's go for the first step of the methodology. So the first step was to create a Mediterranean land cover map. We decided to do our own land cover map because we consider that the sources that are available, for instance, a global land cover map from Copernicus, was not good enough. As we were explaining at the very beginning, the pixel size of the land cover map from Copernicus was 100 meters. We also have the higher resolution layer from Copernicus that is 20 meters, but the definition of forest that they use is not the one that we wanted. And also the accuracy was pretty bad. So we encountered that there were some mistakes. They were, for instance, a lot of shrubland or tree crops included in those layers. So we decided we wanted to create our own layer before going to the definition of forest types. So as I mentioned, the idea was we are going to do our own land cover map, and whenever we are happy with the results, we will take the layer forest and open forest to move to the next step of the methodology, that is separating that into forest types. So this is an example of the first round. Actually, we used data only from Spain. Later, we got data from Tunisia and Lebanon. So we are actually now going into a second round of classification using data from Tunisia and Lebanon. But the first round was using data only from Spain. So these are the classes that we define. Basically, we are copying somehow the classes defined by the Copernicus global land cover. It's up to 9 classes. So we have cities or artificial infrastructures, grasslands, shrublands, rocks, water, wetlands, agriculture, forest, and open forest. And for Spain, we managed to collect more than 30,000 samples. And for Lebanon and Tunisia, we managed to get some extra samples of more than 8,000 from Lebanon and more than 5,000 samples from Tunisia. What we expect at including Lebanon and Tunisia is that we will also include some variability. So these countries have different landscape than the one we have in Spain, and more or less we wanted to have representation from the main 3 regions, so the European region, Middle East, and Northern Africa. Of course, we could improve it, but that's how much we managed to collect so far. So let me show you some preliminary results, and I'm showing you an example here from Spain, a city called Soria. And as a reference, I'm showing you the Sentinel-2 image from 2021, one image of the hundreds that you can get in 1 year. And this is our map, and I will call it the ENVIC2Lab 2021 because this is the name of the project. So at first sight, you can see that first of all, the definition is pretty good because you can even see some roads and even the separation between agricultural fields, they are represented. You can also see some riparian forest along a river. So the definition is pretty good. And as a first sight, if we photo interpret these satellite image, even if we go in high resolution layers of the area, the results look pretty promising. But remember that we saved the 20% of the points to do a validation to quantify the accuracy of our maps and report the errors. So for the case of Spain, we get a 96.5% of a total map accuracy for all the classes. That's actually very, very good. In comparison, for instance, with the Copernicus global land cover, they are reaching an 80%, 80% of accuracy. We got a 96.5. But also, if we evaluate individual classes, we saw that for dense forests, we achieve a 99.9%. That's really, really good. And for open forests that are normally very, very difficult to classify, we achieved a 97.4. So whenever we run again the model with data for Lebanon and Tunisia, we will also have the results for those 2 countries. So let me show you another example from another area, for instance, a Morocco in Tetuan. And also let me compare with existing cartography. So with this, I would like to show what is the contribution this ENVIC2Lab project is doing. So first of all, you can see that the land cover, global land cover product from Copernicus, it has a pixel size of 100 meters. So the definition of certain features is gone. Like for instance, in the ENVIC2Lab is 10 meters. You can see roads, for instance, or even this riparian forest and river that you cannot see in the global land cover product because the pixel size is much bigger. But also we identified as a first sight some problems of classification. So for instance, if you check in this corner over here, it is pretty clear that this is a forest. We classify it as a forest, but it's not classified as a forest in the Copernicus product. It's defined as open forest or shrubland. And also for the forest over here, they are also underestimated in the global land cover product from Copernicus. And for instance, there's a lake that was completely missing. So for instance, this water area over here is completely missing in the land cover map. So the first impression is that our map is better than the existing cartography, but we don't have data at the moment to report the accuracy of our map, because we would need to have field reference data from Morocco to know how good the map is in Morocco. So as we are only covering 3 countries in the Mediterranean region, we decided to organize a hackathon to invite local experts to provide data from each of the countries, and we will use those data to validate the map of a land cover map in the rest of the regions. And I will explain at the end of the presentation a little bit about the hackathon we are organizing these days. Okay, so in the second step of the methodology, basically we will get, whenever we are happy with the map of a land cover class, we will extract open forest and dense forest, and we will divide them into forest types based on the dominant species. So remember that I showed you before the preliminary list. So we expect that we will have 36 classes of forest types and 10 classes of plantations, maybe not so many, we will have to find out. And here I'm showing you the amount of data we managed to collect from the entire region. Just let me tell you that for Greece and for Argelia, I received data recently that is not shown in the map yet. So we have more samples than the ones that I'm showing in this map, but we managed to have more than 80,000 samples. These samples are validated. It means that they are validated to exist in 2021, and the accuracy is more than 250 meters. So it's really high quality data. I mean, we got from the European Vegetation Archive many more samples, but I had to filter the most of the samples, and I only got really high resolution and quality data. So these points are really valid, okay? There's a validation and filtration process. So it's not bad. 80,000 samples is actually a very good number, and here you can see the origin of the data. So first impression you have is that we have data from different sources, right? So I'm summarizing in this table the information about those data sources, and the message that I want to convey here is that since the data comes from different sources, there has to be a preliminary work, and actually it's a very hard work of harmonizing the data inventory, the forest inventories. And for instance, the main challenge is actually that the forest definitions are different, the forest types are different. So there is a first step of deciding how are we going to make these forest databases comparable and harmonized before we can use it for mapping, okay? So basically, the harmonization of the forest inventories are based on 3 levels. So the first level is literature. As I mentioned before, there was a first literature search to find out which forest types exist in the Mediterranean, and I was surprised that there was not an agreement. So the first thing we would like to do, or we are doing actually, is trying to find what definitions are there and try to find a final legend or list of species or forest types that we are happy with. And remember that I'm having the European Union habitat classification in mind, but it's not super, so I will have to modify it as well. The second approach is to do some statistics. So we have more than 80,000 samples. So basically we do some statistics to see where these forest types appear in the region, what are the dominant species, what are the groups of species for mixed forests, how do these species mix in certain forest groups. But also consider all the time that we are doing a map using remote sensing. So there's always a technical limitation. So one big step of defining the forest legend is a spectral analysis of the classes. So basically, whenever we have a preliminary list of forest types that we would like to identify in the satellite images, we would need to check if those forest types look different from the spectral point of view. So imagine an example, and I'm giving you an example, and forgive me that the legend is covering part of the graph because this is a very recent work. We're still working on this. But for instance, I'm listing here the Quercus species that exist in Spain. And also some of them are like a mixed forest. For instance, we have Quercus robur and Quercus petrea form a mixed forest. And I want to see if they look similar in the image. If two Quercus species look very similar in an image, maybe I cannot separate them. So eventually I could identify some Quercus species, but maybe others I cannot differentiate. Okay, so there's also an extra step on the definition of the forest types. So basically, this is an example for the Quercus species in Spain, and we are calculating the average and the standard deviation, or the maximum and minimum reflectance value. And here I'm putting all the variables that we are considering in the model. So we have the three topography variables: slope, aspect, and elevation. And then I have the spectral indexes for spring, the spectral Sentinel-2 bands for spring, and I repeat for autumn and summer. And for instance, I see that for the spectral indexes, all the Quercus look very similar, but for some spectral reflectant bands, for instance, in the autumn, it seems that there's more variability, probably because there are some Quercus species that are perennial and other species that are deciduous, they drop the leaves. So that's, for instance, a variable that might help us to differentiate between Quercus ilex and suber that are perennial trees and other Quercus like robur and petrea or humilis that they drop the leaves in the autumn. Okay. Also, you see in the summer, there's certain separation in colors and the near infrared. In the spring, certain separation, but not so much. What is really interesting here is that there's a lot of separation when it comes on the distribution of these species based on the elevation and the slope, and also the orientation of those slopes. Sorry. So it seems that we will have some chances of separating the Quercus types in Spain. Okay, so let me show you some preliminary results for the Mediterranean forest type map. I'm showing you again an example in Spain. This is our map, the MBIC2 lab, and this is the Sentinel-2 image for comparison. So far, we are only developing the map of Spain because we are still working on the harmonization of the databases of all the Mediterranean basin, but we expect that we will have the map for all the Mediterranean basin in September. Yeah, September, I hope. So, so far also I cannot give you the accuracy of the map because we are still working on that as well. But again, we saved 20% of the points of the Spanish forest database to validate the map. But yeah, eventually I cannot even tell with my eyes what type of forest this is, but I actually can see that there's some color difference between this northern part and this other part. And I see that the map is classified as 2 different species. Also over here, yeah, the colors look a little bit different. So I will tell you soon if we succeeded or if the map is a disaster. But as a first look, it seems that we are separating forest types. So that's all from the work and the progress status of the projects. And let me just finish the presentation explaining to you that an important part of making a map is to validating the errors and the accuracy of that map. And that's done through a process that is called validation. As I was explaining, we will do the validation saving the 20% of the samples. So we will use 80% of the samples to produce the map and 20% of the samples to validate the accuracy of the map. But for the case of the land cover map, we only have data from Spain, Lebanon, and Tunisia. So eventually we could only know how good those maps are in those 3 countries. So what happens with the rest of the countries? I don't have any data. So we decided to organize a hackathon. So we called for volunteers in every Mediterranean country to participate, and we are providing them with point samples randomly spread on an area, and they have to tag those points and tell us what they see. So basically classify them in those 9 classes that I show you for the land cover map. So basically tell me if you see a city or a lake or a forest, an open forest, shrubland, and so on. So we managed to have 45 participants in all these countries, and these are the number of participants per country. So first of all, I'm very happy that we managed to engage people from countries in most of the Mediterranean region. And of course, there are some countries like, surprisingly, France, we didn't get any participants. In Syria and Libya, also not any participant. But in the other countries, they are very, very well represented. So I actually will do a little piece here myself to contribute. Like the vegetation is similar to Spain, I can eventually recognize some classes. And this is the locations that people chose. So basically we asked the participants to choose an area that they are familiar with. And these are the locations that has been selected. And as I say, there will be 46 areas in 16 countries in the Mediterranean region. And we provided every participant 500 points. So at the end, if everybody finishes the work, we will have around more than 20,000 samples. And we will use that to validate the land cover map. That is the first step of the methodology. But also, once we evaluate the map, we will use also those points to make a third round of the Mediterranean land cover map to improve the accuracy of the map. When it comes for the forest types map, we are not going to go so thoroughly in locating points and ask people to give us information each of the points. First of all, because it's really difficult to identify the forest types on an image. So for instance, for the land cover map, we are using as a reference high resolution layers on Google Earth. But even though if you get very high resolution layers of a few centimeters pixel, you cannot tell what forest type it is. So for the second round of validation, we are of course validating the maps based on the database. We are saving 20% of the points to do the validation. And remember that we have data for most of the countries. So every area of the Mediterranean is going to be validated that way. But also we had a call for experts that eventually will look at the map and tell us if it makes sense, if the location of the species that we are identifying in the map, it makes sense based on their own experience, because we are calling people who actually do field work and do research in forest in their countries. So that's basically it from my side. This is the explanation of the project that we are doing. And just to tell you a little bit the dissemination of the work that we are doing, we are presenting our work in several seminars and conferences. So far, we've been in Turkey in March in the Mediterranean Forest Week that is organized by FAO. And we have an article submitted to the proceedings. Then we went to the Living Planet Symposium in Germany in May. That's a very important symposium in the remote sensing community that is organized by European Space Agency. We will go in September to the ForestSat in Berlin. And also explain to you that at least we would like to do 3 scientific papers based on this work. And also we've been invited by FAO to write one of the chapters of the next State of Mediterranean Forest report that will be published in 2023. So to finish, I would like to thank you all, and especially my team, that is the European Topic Center at the University of Malaga, but also a second team at the University of Malaga, that is the Supercomputation Department, and their name is the CHAOS team. And also to all the people who share data. So a big thank you to the European Vegetation Archive custodians that participated in the project, and also all the participants that also provided data from their countries. So here is the list of some of the people that is participating in the project. And on the upper corner, you have my email. So if you have any questions or would like to participate in the project, just write me an email and I will reply to you. So thank you very much. And I come back to you for questions.
Thank you, Dr. Garcia. And yes, indeed, if we have any questions, please either unmute your microphones or type them in the chat. Let's give some minutes for questions.
Is there any questions in the chat, maybe?
No questions, I think. So I guess everything was clear. So everyone has also your email in case of any questions that might arise in the future. So once again, I would like, sorry, yes.
Oh, that's great that nobody has a question.
Yeah.
That means that I explained very, very well.
Yes. Yes, once again, thank you for today's talk. We will be sharing the recording later on today or tomorrow with everyone. And at this point, I would also like to wish you a nice summer break, because we are also coming back with the next invited talk after the summer break. So thank you all and enjoy the rest of the day.
Thank you very much for inviting me. Have a good summer break too.
Thank you.